Lesson 7, Group 3, Partial Fractions with linear or quadratic factors that are non-repeated. Part 2. Example number 7. Decompose the given compound fraction into partial fractions. We have two quadratic factors which cannot be factorized or simplified to have linear factors. You have the compound fraction. The first quadratic factor will attract a linear numerator in this form, as plus b. The second quadratic factor will attract another linear numerator in this form. You find the LCM and simplify. You have it in this form. To clear fractions, you multiply through by the LCM. You are left with this result as equation P. Since it is not possible to find any of the constants at this point, after checking, you observe that there is no common factor, and as such, you cannot make any term to be 0. The only approach to obtaining the solution is to expand equation P and compare the various coefficients to have different equations which can be solved simultaneously. At this point, the only option we have is to expand equation P. You have equation P. The left hand side remains the same. We come here and expand. You use the two terms in the first bracket to multiply the second bracket. You have as times s squared. You have as cubed. As times plus 3s. You have plus 3as squared. As times minus 2. You have minus 2as. You use b times s squared. You have plus bs squared. B times plus 3s. You have plus 3bs. B times minus 2, that is minus 2b. You come here, you use cs to multiply s squared plus 1. You have cs cubed plus cs. Then you use d to multiply s squared plus 1. You have plus ds squared plus d. You bring together the terms that have the same power. as cubed, cs cubed. You factor out s cubed, you have it in this form. Follows by the terms with s squared. You have it in this form. The terms with s, you have this result, the constant terms. Next, comparing and equating coefficient of s cubed, we have ac equal to 0. 0 because in the left hand side there is no term that contains s cubed. So we assume there is 0 s cubed. Next, you compare and equate coefficient of s squared. So you have 3a plus b plus d equal to minus 2. This term that has s squared, that is equation 2. You compare and equate the coefficient of s. You have this term equal to 0. because there is no s in the left hand side. You have this as equation 3. Lastly, you equate the constant terms. That is, this term equal to 1 as equation 4. Next, you solve the 4 equations simultaneously, but you try to arrange them so that you have 2 equations with the same variables. Let us see the arrangement pattern. The solution continues. You have the 4 equations, but only 2 equations with 2 the same variables are needed first. To achieve this, we need to rearrange the equations above as follows. Now, you need to have a target. My target here is to have 2 pair of equations with the variables a and b. That is my target. So, if I come here, I can get ab if I replace c with either a or b. C is contained in equation 1. So I'm going to start from equation 1. Equation 1 is plus c is equal to 0. So I have to make c the subject because I will come here and replace it. So you transfer a to the right hand side and you have c equal to minus a as equation 5. Next, you replace equation 5 in equation 3. This is equation 3. You replace c with minus a in this form. You open the bracket. You have this result. You add like terms. You have minus 3a plus 3b equal to 0. Divide through by minus 3. You have a minus b equal to 0 as equation 6. Next, I can rearrange equation 2 and 4 so that I have another equation in terms of a and b. You must have a target so that your rearrangement becomes very easy. From equation 4, minus 2b plus d equal to 1, I have to make d the subject by transferring minus 2b to the right hand side. I have this as equation 7. Next, you replace equation 7 in equation 2. This is equation 2. You are replacing d with equation 7, which is equal to 1 plus 2b in this form. You add like terms and transfer plus 1 to the right hand side. You have it in this form. You have 3a plus 2b equal to minus 3. Divide through by 3. You have a plus b equal to minus 1 as equation 8. We have achieved the second equation with the variables a and b. So now we are to solve the 2 equations simultaneously for a and b first before we solve for c and d. Solve equations 6 and 8 simultaneously using elimination method. You have equation 6, equation 8. I want to eliminate variable b since the coefficients are the same and the signs are opposite in both equations, I need to add. So a plus a is 2a, minus b plus b is 0. 0 plus minus 1 is minus 1. Divide both sides by 2 in order to get a. So a is equal to minus 1 over 2. To get b, you have to replace a value in any of the equations. I'm using equation 6. A minus b equal to 0. This is the value of a, minus b equal to 0. You transfer minus b to the right for it to be positive. Therefore, b is equal to minus 1 over 2. We have known a and b. Let's solve for c using equation 5. In that equation, c is already made the subject in this form. You replace a with minus 1 over 2 times this minus. You have 1 over 2. To get d, you replace b value in equation 7. This is equation 7. You replace b with minus 1 over 2. That leads to 1 minus 1 equal to 0. You have the compound fraction that is equal to the partial fractions. You replace the various constants a, b, c, and d with what they stand for in this form. If you open the bracket here, you have these results. You have to add the like fractions in the numerator of the first term. When you add them, you have it in this form. This is the second term. You come here and factor out the negative sign. You have this result and the second term. If you divide, you have this final result as the required partial fractions. End of lesson 7. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.